Welcome to the technical information video for the Digital Plant Experience Line Integration Concept Demo. In this video we will have a look at the operator screens provided by the line integration application example. We will learn what information they provide and how the information can be used in order to improve the productiveness of the customer's filling or packaging lines. This is the plant overview screen. It shows the status information of all implemented filling and packaging lines as well as some basic KPIs. The status is color-coded. Green means everything is running well. A darker green indicates that the line is still producing but not with the expected speed, which will result in performance losses. If the color of the line status is yellow, the line came to a stop, but the fault is not caused by the main equipment, which is usually a filling machine. Usually this happens when some other machine in the line is having a fault situation, and this situation ultimately causes the filling machine to go into a lack or tailback state, depending on where the faulty machine is located in the line. If the line stoppage is caused by the filling machine itself, the line status will be indicated in red color. If we want to see details of the machines within a line, the according line can be selected from the line selection menu. This will open the line overview, where we quickly get an overview of the status of all machines of that line. As we can see here, all machines in the line are running, indicated again by green color. If machines are in a fault, the status color will change to red. Machines in lack or tailback situations will be indicated with yellow color. The line overview gives information to line supervisors or line managers if there are any machines in the line that are in a fault and need the operator's immediate attention. Currently, besides the machine status information, there is no additional information shown. This can be changed by selecting one of the 4 configured user roles from the demo menu. If the line coordinator is selected, the machines will display KPI information as well as the order that is currently running on the line. Right now, there is the no order label on all the machines because no order has been assigned to the line yet. For demo purposes, this can be changed by opening the small order management screen in the lower left corner. Clicking through all the 4 order ID input fields will clear them out. After that, order IDs can be generated by clicking on the Create button. Select a product from the drop-down menu and then click Start Next. This will set the first order active and the order ID will be displayed on all the machines. This also provides the data for the order progress information on the line dashboard that will be shown later. If we want to see more details for a machine, we can click on it. It will bring up the machine details view. There, we can select from a variety of different information. Right now, we see some status information on the left side and speed information on the right side. The status screen shows information that comes directly from the Plant Data Interface, or PDI, like the machine uptime, the consumed electrical energy as well as set point and design speed. There is also a bar that displays the ratio between current machine speed and set point speed. Usually this should be at 100%. If this is often not the case, it should be checked why the machine is not reaching its target speed and therefore losing performance. If the machine provides more energy data via the Plant Energy Concept, or PEC, interface, this energy can be tracked and visualized in the Plant Energy views. Another very helpful information screen is the alarm display. Here, the occurred alarms on the machine can be analyzed. For the filler, which is also one of the main or bottleneck equipment in filling line 1, there is also the root cause analysis, or RCA information available. The RCA is an optional, customizable module that, once configured and parameterized correctly for a specific filling line, runs silently in the background and monitors the alarm information of all the machines in the line. Once the main equipment has come to stop because of a lack or tailback situation, the RCA will look for the machine in the line that, due to an earlier internal failure, caused the lack or tailback situation on the main machine. This information gives a clearer picture why the line is not performing at its optimum. RCA information can be shown by clicking on the icons in the RCA column. Usually, every stop of the filler that has been categorized as an upstream or downstream reason will have the according RCA information if the analysis was successful. As seen in the example here, this selected stop of the filler was due to a problem of the labeler where someone opened the front door. There is also a hit list available, that shows all the machine's alarms sorted by occurrence. This is shown here on the washer. This information helps to identify the most occurring problems on a machine in order to fix those problems first. The hit list can be shown by first clicking the All Messages button and then clicking the Message Occurrence and Duration button. Also, the time frame for the analysis can be selected. Here, we chose today. As a result, we can see that today the washer had 29 occurrences of a blocked discharge. Since we know that this problem is not related to the washer itself but to another machine downstream in the line, we look at the next entry. There, we have 5 occurrences of a blockage due to damaged product with a total duration of 19 minutes and 36 seconds. Depending on the average occurrence of this specific fault, this can give an indication that there might be a mechanical problem at the washer that causes a higher bottle damage than expected and is worth being investigated. Another information would be the KPI display. Here, the 4 standard KPIs OEE, availability, quality and performance are displayed for the currently selected machine. The calculations are based on the current shift and there is also a comparison to the values of the last shift. Back on the line overview, we can also have a look at the line details view. It is accessible from the side menu. The line details view is very similar to the machine details view, however here we can compare 2 machines from the line whereas the machine details view was specific for the machine we selected on the line overview. Right now, we can see for the blow molder the unit status information on the left and the speed overview on the right. By selecting other information screens from the selection menu at the bottom, we can switch through the information screens. For example, we can bring up 2 KPI information screens and compare the filler with the filling tri-block to see if they are performing differently. Any machine that is configured for the line can be selected. For projects, it is possible to create customized information screens and add them to both the machine and line details view. The modular structure of the HMI screens keeps the effort to integrate new screens at a minimum. Let's have a look at another helpful information screen. This is the line dashboard. Its purpose is to show the most important information for the selected filling line. The dashboard is divided into several sections. In the upper left section, there is a display of the line status. It shows information about the current production situation of the line. In this example, we look at filling line 1, which compared to filling line 2, has 2 filling units. Hence the line status depends on the combined status of both the filler and the filling tri-block. Right now, we can see that the line status is in reduced speed. This is because the filling tri-block is having a fault, as it is indicated and highlighted with red color. We can also see as additional information, that filling line 1 is supposed to run with 320 units per minute, which of course is under normal conditions. Since there is only 1 filling unit running, the current speed of the line is only 160 units per minute or 50%. This is indicated by the gauge control, displaying the ratio between the current speed and the line speed. In the bottom left corner, we can see the order progress information. It displays the ratio between the actual produced quantity and the scheduled production quantity. It also gives an indication about the remaining production time for the current order, giving the line manager valuable information if production is still aligned with the production schedule or if rescheduling is necessary. The remaining time is calculated based on the remaining production quantity of the current order and the line speed value. It also factors in the current performance rate, leading to a more reliable remaining time because lower performance rates prolong the remaining order processing time. In the top right section, the 4 standard key performance indicators, or in short, KPIs, are displayed. They are being calculated for the current shift. The value range is color-coded. For example, if the value of the OEE is 60% or higher, the value is within the target range and no signal color is used. If the value is between 30 and 60% like right now, the value is highlighted in yellow color, giving indication to the line manager that the value is below the target but still in an acceptable range. If the value drops below 30%, the line is critically underperforming and the OEE value is highlighted in red color. It can be an indication that maintenance activities are required. Please note that the value ranges mentioned are only an example and can always be adapted to the specific needs of the project. In the middle right section, we can see an overview of a couple of time categories the filling line has been in during the current shift. Fully productive time is measured as the time when both fillers are operating. Speed loss is the time during which only one filler is operating. The line is in an internal fault when both fillers are in internal faults at the same time. Whenever the line has been stopped because both fillers can't operate anymore because of a lack or tailback situation, this time is accumulated in the external fault time category. As we can see here, up to now for 24 minutes in the current shift, production time was lost because of the faults of equipment other than the fillers. To get more information why the filling line was losing productive time, the next information section can provide valuable insight. This section shows the result of the root cause analysis, or RCA in short. The information shown here is basically a hit list. It shows the equipment that has caused the most stops on the main equipment, also providing detailed information about the nature of the equipment's failure. As we can see here, both the filler and filling tri-block were stopped several times because of the labeler, which always had failures due to a blockage caused by damaged product. In this example, the line manager can use this information to send the maintenance specialists to the labeler to see what is causing the issue and remedy the problem, leading to a higher productivity of the filling line. When we want to know quickly what was happening on the machines in our filling or packaging lines, we can make use of the Gantt chart. To access it, we click on Line Justification from the side menu. The Gantt chart graphically shows the historical machine state information for all the machines of the selected line by displaying color-coded time slices. The application example comes with pre-configured color settings, which of course can be changed according to the customer's preferences. Currently, the main colors being used are green, which indicates a productive state. Yellow is indicating external faults like a lack or tailback situation, and red colors indicate internal equipment faults. With that information, we can quickly get an idea if the machines in our line were performing like expected or if there were any major stoppages or downtimes. As we can see here, there was a major fault on one of the line's main equipment, the filler. By hovering over with the mouse, we can get more information on the problem. The system tells us that for more than 2.5 hours the filler was having an other internal fault, which usually is being reported whenever the machine can't provide enough information in order for the system to specify the fault in detail. What can be done here now is to manually specify a more detailed fault. This information can be helpful later in the reports to get a clear understanding of the faults that happened on the machine. Sometimes it is also helpful to split a fault and assign separate status information. For example, the machine could be in a fault and after some time, the maintenance or repair specialists will take actions to repair it. It could be interesting to know over time, for how long machines were in maintenance or under repair. To split a machine state, we can right-click on it and select Split from the context menu. We can define at what time mark the split should occur. We can see now that we have two separate time slices for the other internal fault. We will assign the maintenance status for the second one. To do this, we right-click again on the machine state and select Edit from the context menu. A list with all the configured machine states will show up. Of course, this list can be edited to add more user-specific states, for example more detailed stop reasons. Down in the list there is the maintenance state we're going to use. After saving it, we can see that the Gantt chart is updated now with the maintenance status for the filling machine. Please remember that changing a machine status might affect the results of all active calculations that use this status, depending on the calculation configuration. Finally, we have a look at the reporting. The line integration demo comes with a few exemplary reports that show some of the reporting capabilities. The reporting functionality is implemented in PM Server, which is part of PM Analyze. The report layouts are being designed in Microsoft Excel. PM Server uses those templates and fills it with the according data every time the report generation schedule is executed. After that, the Excel file is being printed to a PDF file. Let's have a look at one of the reports. The reports are automatically created every day and stored in a subfolder of the WinCC project. To access the reports, bring up the Explorer and navigate to the WinCC directory. Inside, there is a subdirectory named PM. This contains the PM Server configuration, the PM Server runtime data archives and both the report templates and the created reports, which we can find in the accordingly named directories. Let's have a look at the KPI Shift report. The report is divided in two sections. The first section with pages 1 to 3 contains information for filling line 1. The second section with pages 4 to 6 contains the same information for filling line 2. This report's first page displays the standard KPIs for all 3 shifts during a day. We can see the morning shift, the late shift and the night shift. On the second page, we have a direct KPI comparison for all 3 shifts. We can see that concerning the OEE value, the night shift was performing better than the other shifts. With the help of reporting, it can be tracked if this is a continuous phenomenon and analysis can be performed, why this is the case. In the best case, conclusions can be drawn to also optimize the OEE of the other shifts. Furthermore, on this page there is the display of production information, basically how many bottles have been filled in each shift and how many rejects were being discarded from production. The third page on the report shows information about the production times which give a quick overview if there were major problems on the line during a shift, which would be indicated by a high value of external or internal fault time and analogically, a reduced operating time. For more information on the DPE line integration concept, please visit the Siemens Food and Beverage SharePoint. The application example that has been shown in this video can also be downloaded from the Siemens Industry Online Support. If you want to get in contact with the persons responsible for the DPE line integration concept, you can also write an email to the following address, dpe-contact.de@siemens.com. Thank you for watching.